So it's quite technical here, and but we've got the original big data set here. Again, you can go back and choose a country that you want to analyse. Here's Spain. Now that this tab's getting pretty messy. I've got quite a few charts there, or graphs if you like, and I've got data sets, the same data set but in various parts. What I'm going to do is I'm going to look at the date reported and the total number of cases. I'm really going to get into this because this is what I want to do some extra analysis. I'm going to go into sheet 3. I'm going to do edit. I'm going to do paste special, paste values, because if you do edit paste values, then that's great. But look what's happened. This date has actually now changed as well. So let's go back here. It's sometimes fraught with disaster when you do paste special and the values. So Command C, let's go back here. Let's do Command V. And okay, so that seems to be okay. So it's pasted the dates as they are, and it's recognised the dates, and it's pasted these numbers, which look great. Oh yeah, remember the numbers we had here, these were paste special from before, the total cases. In the first column, the total cases here, this is where we had a formula to work out the total cases. This was like a cumulative total. We were doing kind of, the cell above plus the cell to the left. Okay, so because we didn't copy and paste these guys here, which are a formula, we copy and pasted these guys here, which is just numbers, then it was absolutely fine. So in here, I'm going to cut Spain total cases. All right, so now I'm going to do a bit of analysis here. I want to really drill into the idea of what's going on here. There's only minor cases. Well, no case of COVID-19 is minor, of course it's not. But there's a small number of cases here, 1s and 2s and 3s. What I'm going to do is I'm going to start to code this a little bit. I'm going to kind of get rid of these dates here, because if you think about these graphs here are meaningful. You can actually see exactly what the date is, and that's really powerful. Okay. But working with dates and trying to create mathematical models is quite difficult in one sense. It'd be far easier if these were just numbers here, 0, 1, 2, 3, 4, 5. But if you change it to 0, 1, 2, 3, 4, 5, you need to know what does the 3, 4, 5 mean? What's it in relation to? So that's what we're going to dig into now. I'm going to click on A. I'm going to insert column right, and here I'm going to put day. Okay, so this is going to be day, and I'm going to choose a starting day, and a starting day is going to be day 0. So what is going to be day 0 for when I actually start to really notice the total number of cases in Spain? What's a trigger for maybe a government intervention? You think back to all the reported cases worldwide. Was there a particular number of total cases reported where governments really thought, oh crikey, this is getting serious, we've got to try and put in measures, or was there not a magic number? So we're going to arbitrarily choose it here, and I'm just going to go down here, and I think I'm going to choose where the total exceeds 100 for the first time, and I'm going to call this day 0. So you can see I've gone on the 3rd of March. Is that right? Is that what it is? Yeah, the 3rd of March I'm going to call day 0. And on day 0, there's 114 total reported cases in Spain. Okay, so now every day from the 3rd of March is going to be one day after. So the 4th of March is going to be day 1. It's one day after the total first hit 100. So I'm just going to fill this in here just as a kind of a significant point here. Now, so I just need to put the 0, 1, 2, 3 here. There's an easy way of doing that. You can put a formula in, but also you can put in 1, 2. If you highlight both these numbers and then double click, it'll just carry on the pattern. Okay, so now can you see I've got from day 0 up to day 34. So if you think day 0 was 114 cases, that's when the magic 100 number was triggered, then in only 34 days after, you've got to 130,000. That's just totally insane. You've gone from 100-ish on day 0 to 34 days later, 130,000. That is just crazy. Okay, so what we're going to do is we're also going to analyse a subset of this, because for sure I'm going to go down here and look at the details down here. But at the starting point, I am just going to look at what the guidance says, the first 20 days. So the first 20 days, and again, it's not the first 20 days way up here, because not a lot is happening the first 20 days. There's no triggers there to the governments to act. The first 20 days, many governments were completely static. But surely the first 20 days from there being 100 cases, things really happened. So what I'm going to do is I'm just, again, take out this data here. I'm going to go up to 20 days. Command C. I'm going to go up to here. I'm going to Command V it. I'm just going to look at, just eyeball the data. Does it look as if it's pasted okay? Do I need to do just paste or paste special? And then Command C for the headers. Command V, okay? And then really I'm just going to look at these two variables. So days going to be on the x-axis. I'm going to do some more graphs, of course. And the total cases of COVID-19 reported is going to be on the y-axis. And I want to get a feel of how fast this is growing, because this ties in with one of the first student exercises you did. I want to know the percentage change from 114 to 151. What's the daily percentage increase? And I also want to know from 151 to 200. Okay, there is an easy way of doing that with spreadsheets, because you're going to do some repeated calculations. Let me just zoom in a little bit on here. So over here, so in here I'm going to put a formula equals the number to my left divided by the cell above it. That's 1.32. Now think what that is. This is a multiplier of 1.32. It means 114 cases times 1.32 gives 151. So this is the multiplier. Now this, you should kind of recognise that that's a 32% increase from the day before. So total cases 114 on day 0. On day 1 it's 151. That represents a 32% increase. Okay, now you can do that formula anywhere. Look in here, equals the total number on day 19 divided by the total number on day 18. And down here this is a 25% increase, 1.2475, 25% increase. Now all of these multipliers will be obviously slightly different. Okay, now we don't obviously need to type in a formula every time, because the formula just drags down. So if we just drag down by bottom right and dragging down, or even easier, bottom right and double click, we've got the formulas here. Okay, I'll just drag down this last one here. Okay, and then you're thinking, well, what's really the point of this? I'll just type in multiplier here, and I'll put a slash, and let's make it more specific. Daily. Okay, no. Multiplier is going to be here. Okay, let's just put this as the multiplier. Bold. And if I click on H to make these numbers a bit more manageable, up here, can you see there's a decimal increase, decrease. So if I decrease the decimal places, it's going to make these numbers a bit more manageable. So I'm going to round them off to 2dp, okay, and that's all right. That looks good. Click on H, and I'm going to tighten up, center it. I'm going to just put a border cells around it. The borders here. These are all in the front. Okay. So look, there's a 1.32 multiplier, 1.32, 1.31, 1.43, 1.15, 1.37, 2.04. Whoa, that's ridiculous. So this is the multiplier here. Okay, so there's the multipliers: 1.32, 32% increase, 32%, 31% increase, 43% increase, 15% increase, 37% increase. What does 2.04 mean? If I've got 2.04 of the previous day, what kind of increase is it? Yeah, well, that's actually a 104% increase. Things have doubled. Look, things have doubled from the day before, from 589 to 1204. There's a doubling here. So between the 9th and 10th, things started to get super serious. And again, when you drill into the reading, maybe that's because there were just more tests being done. Maybe there was an influx of new testing kits. These are the deeper details that you guys are going to dive into when you start to put your reports together. Okay, so can you see that after this, 104% increase, 36%, 31%, 40%, 41, 36, 35, and then signs and glimmers of hope, because after being in the 30s and 40s, after day 13, things start to, things are still increasing, and that's a scary thing. The numbers are still going up, but the percentage change is 19%, 22, 23, 25, 17, 25, 15. So this is kind of encouraging, I suppose. Okay, so what we'll do down here is we'll just take the average of all the multipliers. So this kind of mirrors the work you did by hand in one of the opening lessons. Okay, and so on average, there's a 33% increase over the first 20 days of reported cases. Okay, so there's the total cases each day. On average, a 33% increase in the total number of cases. I mean, sometimes it was a little bit less, sometimes a bit more than the 33%. So now, if we had to work out a model by hand, okay, or a model by hand, then we might do something like this, that is t for the total number of cases equals, this 114 is going to play a part, 114, because that's the number of cases at 0 days, and then you're going to have a little times, and then you're going to have the multiplier, and that's going to be 1.33. That's going to be 1.33, and then that's going to be powered up to the power of basically d, the number of days. Okay, so that would be the formula that we'd kind of create by hand as a best guess for how the total number of cases t. Okay, so where t equals total cases, and d equals, and this is important, look, not number of days, but number of days after 3rd of March 2020. Okay, so basically, you know, d equals 0 equals 3rd of March 2020. Okay, so if we're doing all this by hand and having a best guess for what you know, a model might look like, this might be the model. Okay, then we could use this model to make predictions. You know, if on average the percentage increase was 33%, multiplier was 1.33, we could use this to now maybe predict beyond 20. But of course, you can see that where this is leading. It's quite dodgy to use this model here based on the first 20 days since the 3rd of March to make further predictions, because already you can see that the multiplier went up, and now the multiplier is decreasing. So I think there's some hope for the future years here that the scary numbers aren't going to be maybe as scary. So maybe we could analyse the next few days and see what might happen there. Okay, so that's our manual model by hand, but I believe we're going to use the built-in tools also to find the best fit regression model. And so for that we need a graph. Okay, so the simple thing is that we're going to do day against total cases. So click, I'm going to drag down for the 20 days, I'm going to insert a chart. That's beautiful, isn't it? Well, mathematically it's beautiful. I mean, humanity, it's terrible. And I'm going to change this into an XY scattergraph. Okay, so when we're trying to fit models, best for an XY scattergraph. Okay, and this is exactly how we saw it. You know, this is exponential growth. It's got this upward curve here, and then what we're going to do is we are going to ask and customize here. We're going to look at series, legend, horizontal axis. We've got lots of different things we can click on. Look at the chart style here. You can change the look and layout, the background color. I just tend to have it, you know, very blank. I don't know if the background color helps that much. Okay, so I'll go none. None. Background color is white. Better. Okay, chart and axis title. We'll get into that. You can actually, I can just double click and change this, and you can point and click and change the size, or you can do it from here. Here's the series, and in the series you can change the color of the dots if you want to. I'll just have it as the default maybe. And then this is the extra bit we want. Look, for the scientists, we've got some error bars here. I don't know that the error bars are so pertinent to us for our mathematical analysis, but there's an option for error bars. Percentage error bars, or constant error bars, or standard deviation, but it doesn't make sense really. So we'll have none there. Data labels, if you like. You know, that could be useful. You know, could be useful. Click them off, and then for us, it's going to be this, the trend line. Okay, and so this is where we're going to get our best fit model. Okay, now you can see that a linear model just doesn't make sense. So we're going to get rid of that. And you know, you've heard the word. It's actually exponential, isn't it? It says the percentage growth, so exponential. And look at that model. That's ridiculous, isn't it? Okay, now this is the best fit model for all the data points we've plotted. Okay, so now let's just have a little look. If we put the label on and use the equation here, it tells us what the equation is that it's using. And it's a very different equation, it's a very different exponential equation than the one we made. Okay, it's the way that the Google spreadsheet is set up. Because this is 304 times e, so e is a magic number 2.71. So the way this is structured in terms of a exponential model isn't a great exponential model for us to really get our heads around. We'd have to play around with the maths a little bit to think about, well, what does this actually mean? What does this e to the power of 0.233x mean? Okay, so we'll come back to this in a later video, and we'll think about a better way maybe of getting that model. In terms of the alternatives, well, that is the only exponential we have. We've got polynomial, but it doesn't make sense to try and fit a polynomial. Look, this is an x squared model. Why would we want to fit an x squared model? Because we know that it's a percentage growth model. It doesn't make sense just because it looks good. It doesn't really look that good. Look at this area down here. And if you go to a power series, this doesn't make much sense either, and it doesn't even fit very well. Okay, a moving average, maybe, but not really. Okay, so the best thing is definitely exponential. The exponential that it's fitted looks very good, but the actual equation of it is a bit confusing on Google Sheets, and that's when we kind of switch to other mediums to try and get this equation and look at the fits basically, and so that's what we're doing in one of the next videos.